Okay, once we have achieved a B coefficient of 0.96, we can now proceed to stage 1 of the triaxial, which is you need to consolidate the sample. Okay, the consolidation stage. Now in consolidation stage, we need to first identify what is the effective stress you would like the sample to be consolidated before the start of stage 2, that is the shear. Now in this case, let's decide that sigma prime should be 100 kilopascal. So I've decided the sigma prime or sigma dash to be 100. If I go back just a few lines back, my sigma value was 350 and pore water pressure was 345. Now I had increased 350 for 345. I had already, so in other words, my pore pressure, it's important to note, pore pressure of 345 was necessary to dissolve all the air. So that's dissolve all the air. So in other words, I cannot go less than any value less than 345 is not, in other words, okay, in other words, my pore pressure cannot fall less than 345, because anything less than 345, my air which is dissolved will come back. So I need 345, more than 345 of U value. So my sigma value should definitely be 345 plus 100. So it cannot be less than 445. So let's make it into a round number. Say maybe 450 is my sigma value. Okay, and then I need, for consolidation, I need a back pressure. I'm going to open up the pore pressure valve. So I need the drainage should occur against a back pressure of 350 kPa. So in this figure, what I'm going to do is the water pressure or the cell pressure is going to be 450. My pressure line, which is below the sample, that's a T junction, I'm going to make it as 350. What happens is, once I open up this valve over here, the pore pressure which is inside the sample, so inside the water will escape out from the sample and hit against the 350. So what you'll notice is, from water will escape from higher pressure to a lower pressure until it stabilizes to a value of 350. So in other words, ultimately when all consolidation is over, the pore water pressure within the sample would be 350 and the cell pressure outside would be 450. So back pressure has come in handy, not only in saturation but also in consolidation stage. This comes to the end of stage 1. In stage 2, I will now, if I do a consolidated undrained test, I will close up this valve, meaning my 350 kPa of pore pressure is now trapped within the soil sample. I have closed it, and then I apply an additional delta sigma, an additional axial load, which is my deviator load from the top. Now because of this delta sigma, my pore water pressure is again going to increase. So remember this chemtense equation which we had. So this time it's delta sigma 3 A times delta sigma 1 minus delta sigma 3. So in this case, okay, so this equation leads to delta U equals to B value we have just seen was 0.96, and I'm going to assume this as 1. Delta sigma 3 is the change in cell pressure. In this case, we have In stage 2, if I just go up, in stage 2, we keep the cell pressure constant at 450 and we are only applying additional load from the top. Right, that's the additional load. I hope you can see this arrow, thick arrow coming from the top. So in other words, this delta sigma 3 is 0. A times delta sigma 1 is the same as delta sigma here. So I get delta sigma, that's my equation, Kempton's equation has reduced to. Now I can, in the usual case, if I'm doing an undrained case, my delta U is measured quantity from the triaxial test. Delta sigma 1 is the one which you have applied. So in other words, I can now calculate A at every step of the loading. You must remember that A is always change. It's a change of pore pressure and divided by change in sigma. So whatever is the change in sigma, it starts from the end of consolidation. So please do remember my change. So deltas U or delta sigma are measured from end of consolidation. So all changes are measured with respect to once the consolidations are over. Of course, if this was a drain test, if I go back, instead of a CU test, if I was doing a CD test. So in CD test, I would have then permitted, okay, I would have then, if I just erase this thing out, please, okay, I would have then permitted the water to escape out from the sample. So water could have escaped out. So because of any additional load at the top, the water could have escaped out, and this escape out of water would be against a datum value of 350. So this pore pressure within the sample will never ever increase more than 350 in case of drained. So my CD test, my sigma is going to change from 450, is going to go higher, but my pore pressure will always remain 350, always fixed, because I allow this water to drain against a 350 kPa, which acts like a a reservoir or a datum. So anything higher or even lower, because your pore pressure can even drop if the sample is over consolidated. Even in that case, my pore pressure the 350 will still try to maintain and fix this value. Okay.